My name is Daisuke Akiyama, Chief of Radiation Protection at IMRAM. Today, I will explain safe handling of radioactive isotopes and nuclear fuel materials at the IMRAM RF facility. This lecture is a part of the radiation safety training for RI and accelerator users. Today's topics are user guides to handling of RI and nuclear materials and effect of radiation for human body. Please note that the following slides will be narrated by a synthetic voice.
This slide shows an overview of the RI facility at IMRAM, Tohoku University. At this facility, we can handle 51 nuclides, including alpha, beta, and gamma-emitting radioisotopes. We also handle nuclear fuel materials such as uranium and thorium for research purposes. Because various radioactive materials are used here, strict safety control is required. This slide shows an excerpt of the available nuclides in our RI facility. You can see the nuclide name, storage location, and maximum capacity. Before planning any experiment, please confirm whether your required nuclide is available and whether the amount is within the permitted limit. When using nuclear fuel materials such as uranium, thorium, or plutonium, several items must be clearly defined. These include the type of material, usage period, annual usage amount, purpose of use, and experimental procedure. This information is required for legal compliance and radiation safety management. Please consult with us to ensure that all details are appropriate before conducting the experiment. This slide shows a map of the RI facility. Areas marked as hot area mean controlled areas for radioactive materials, not high-temperature zones. Entry into these areas is strictly controlled, and only registered users are allowed to enter. The hot laboratory consists of 8 rooms designed for different research activities, including chemistry, process engineering, analysis, and radiochemistry. Each room is assigned a specific function so that radioactive materials can be handled efficiently while maintaining strict safety control. This separation of functions helps reduce unnecessary movement of materials and personnel, which is important for contamination prevention. In addition to these rooms, the facility is equipped with dedicated spaces for solid phase and liquid phase analysis, as well as a radioactivity measurement room. These rooms allow accurate and reliable analysis while ensuring that radiation measurements are conducted in an appropriate and controlled environment using specialized equipment. Each room is carefully designed to minimize both contamination and radiation exposure. This includes appropriate shielding, controlled ventilation, dedicated equipment, and clear operational rules tailored to the type of work performed in each space. By working only in the designated rooms and following established procedures, users can safely conduct experiments while keeping radiation exposure as low as reasonably achievable. This slide introduces important safety equipment installed in the controlled area to ensure radiation safety and prevent the spread of radioactive materials. The entire hot area is maintained under negative pressure, which means that air always flows from outside into the controlled area. This pressure control system is a key safety feature that prevents radioactive materials from leaking into surrounding spaces. All air exhausted from the hot area is passed through nuclear facility-grade HEPA filters before being released into the environment. These high-performance filters are designed to capture radioactive particles and aerosols with very high efficiency. Continuous monitoring is conducted to confirm that the filtered air meets safety standards before discharge. In addition to air control, drain water generated inside the hot area is not released directly. All drainage is collected and stored in dedicated tanks, where it is carefully monitored and checked for radioactive contamination. Only after confirming that contamination levels are below regulatory limits is the water disposed of appropriately. Through the combined use of negative pressure control, HEPA air filtration, and strict management of drain water, the facility maintains a high level of environmental and occupational safety. These systems operate continuously in the background, supporting safe research activities and protecting both users and the surrounding environment. This is the storage room for radioactive isotopes and nuclear fuel materials. Thick concrete walls provide radiation shielding, and high-dose materials are stored in lead-filled safes. Only authorized staff are allowed to access this room. This slide shows the storage room for radioactive waste at the facility. Non-alpha radioactive waste is collected and disposed of by an authorized external contractor according to established regulations. However, waste containing alpha-emitting nuclides or nuclear fuel materials must be stored on site for long-term management. Because these materials require careful control and cannot be easily removed from the facility, proper storage is essential to ensure radiation safety and regulatory compliance. For this reason, strict waste separation rules must always be followed. Users must correctly classify waste according to radionuclide type and contamination level, and place it in the appropriate containers as instructed. Improper segregation can lead to serious safety issues and increases the burden of waste management within the facility. In addition, since waste containing nuclear fuel materials or alpha nuclides must remain stored, it is very important to minimize the amount of radioactive waste generated as much as possible. Careful experimental planning, efficient use of materials, and avoidance of unnecessary contamination can significantly reduce waste volume. By reducing waste generation and following waste management rules correctly, we can maintain a safer working environment and support the sustainable operation of the RI facility. To work with radiation at Tohoku University, you must be registered as a radiation worker. This requires submission of an online form, safety lectures, and a medical examination. This lecture corresponds to the facility-specific training requirement. If you are a synchrotron beam user, you may take only Course A. If you are an unsealed RI or accelerator user, you need to take both A and B courses. If you have not received your glass badge, please contact the Human Resources section in IMRAM office. In the hot area, basic safety rules must always be strictly followed to ensure a safe working environment. Smoking and eating are strictly prohibited, as these activities greatly increase the risk of internal contamination and the unintended intake of radioactive substances. Users must never bring food, drinks, or smoking materials into the hot area. All users are required to wear appropriate protective clothing, such as designated lab coats, gloves, and shoes, to prevent radioactive contamination of the body and personal belongings. Proper use of protective equipment is essential for minimizing exposure and preventing the spread of contamination outside the controlled area. In addition, all activities must be accurately recorded, including entry and exit times, handling of radioactive materials, and waste management. These records are important for radiation safety management, traceability, and regulatory compliance. In the event of an emergency, such as contamination, fire, or other incidents, users must immediately notify people nearby and inform radiation protection staff. At the same time, every effort should be made to prevent the spread of contamination, following established emergency procedures. Prompt reporting and appropriate actions are essential to protect personnel and maintain safety within the facility. This slide shows the entrance and exit procedures for the controlled area. To enter the controlled area, you must use your personal ID card, which confirms that you are a registered and authorized radiation worker. Upon entering, all users are required to wear appropriate protective clothing, including lab coats and designated shoes prepared specifically for use in the controlled area. These items help prevent the spread of radioactive contamination and must not be worn outside the controlled area. Before exiting the controlled area, contamination checks are mandatory. Users must carefully monitor their hands, clothing, shoes, and any carried items using the designated contamination survey instruments. This procedure is essential to confirm that radioactive materials have not been inadvertently transferred outside the controlled area. In addition, external users are also required to meet the certification requirements for radiation workers, including appropriate training and medical examinations. Only individuals who fully satisfy these conditions are permitted to enter and work in the controlled area. By strictly following these entrance and exit procedures, we can maintain a safe environment, prevent contamination spread, and ensure compliance with radiation safety regulations. These are personal dose meter. In this facility, electric dose meter for visitor glass badge for registered users are used. Glass batches are used according to the experimental details. If you need to change the batch, please contact us at least 1 month before the experiment. In other facility, OSL dose badge are used in some cases. Please follow the facility rule. For example, at Spring 8 and KEK, please do not forget to bring the glass batches from IMRAM. To prevent contamination, protective measures such as plastic trays, draft chambers, and polyethylene sheets are routinely used during work with radioactive materials. Plastic trays help confine any spills or scattered materials, preventing radioactive substances from spreading to benches or the floor. Draft chambers provide controlled airflow to limit the dispersion of radioactive aerosols or dust, while polyethylene sheets cover work surfaces and enable easy decontamination after experiments. Before starting any work, users must carefully prepare their working area by setting up these protective tools in advance. Proper preparation reduces the risk of accidental contamination and ensures that radioactive materials are handled in a controlled and isolated manner from the beginning of the experiment. Well-organized workspaces also contribute to safer and more efficient operations, allowing users to focus on experimental procedures without unnecessary risks. By consistently applying these contamination prevention measures, radiation workers can effectively minimize the spread of radioactive materials and maintain a clean and safe controlled area. Handling of nuclear fuel materials, such as uranium and thorium, is strictly permitted only in designated rooms and approved facilities. These areas are specially designed and equipped to ensure proper radiation shielding, contamination control, and compliance with safety regulations. Users must never handle nuclear fuel materials outside these authorized locations. In addition, prior consultation with the Chief Radiation Protection Officer is mandatory before beginning any work involving nuclear fuel materials. This consultation ensures that experimental procedures, quantities, and handling methods are appropriate and that all necessary safety measures are in place. Users should not proceed with handling unless explicit approval has been obtained. It is also essential to carefully check the labels and signs indicating authorized areas before starting work. These labels clearly show where nuclear fuel materials can be used and stored. Ignoring or misunderstanding these indications may lead to unsafe conditions or regulatory violations. By following these rules and communicating closely with radiation protection staff, nuclear fuel materials can be handled safely, legally, and responsibly, ensuring the protection of both personnel and the facility. Radiation protection is based on 3 principles: shielding, limited time, and distance. Wearing protective equipment and minimizing exposure time are very effective measures. After completing experiments, contamination must always be carefully checked using appropriate survey meters. This step is essential to confirm that radioactive materials have not spread to work surfaces, tools, protective equipment, or the user's body. Contamination checks should be conducted methodically and without omission before leaving the work area. Different types of detectors are used depending on the radiation type, as alpha, beta, and gamma radiation have different characteristics and detection requirements. Therefore, users must select and use the correct survey meter for each radiation type to ensure accurate and reliable measurements. It is particularly important to pay close attention to areas that are frequently touched, such as gloves, lab coats, shoes, and hands. Even small amounts of contamination, if overlooked, can lead to unintended spread outside the controlled area. For this reason, users must always confirm contamination levels before leaving the controlled area, and report any abnormal readings immediately to radiation protection staff. Careful contamination monitoring is a fundamental responsibility of all radiation workers and plays a critical role in maintaining a safe working environment. In case of an emergency, your first and highest priority is always personal safety. You should immediately stop your work and make sure that you and the people around you are not in danger. Do not rush to continue the experiment or attempt unsafe actions. After ensuring your own safety, the next important step is to prevent the spread of contamination. This includes restricting movement, avoiding unnecessary contact with contaminated areas or materials, and following established emergency procedures to limit the affected area as much as possible. At the same time, you must immediately contact radiation protection staff or senior personnel and report the situation clearly and honestly. Quick communication allows appropriate response measures, such as decontamination, monitoring, and risk assessment, to be taken without delay. Never hide accidents, incidents, or contamination events, even if they seem minor. Early reporting is essential for protecting personnel, preventing secondary exposure, and maintaining a safe and transparent working environment. Reporting an incident is not a failure, it is a responsible action required of all radiation workers. This section explains the effects of radiation on the human body. The effects depend on the dose and exposure conditions. Understanding dose levels helps reduce unnecessary fear. This slide shows comparison of exposure doses. Left side is radiation south from artificial radiation. For example, exposure doses of chest X-ray mass examination per once is 0.06 MSV. Gastric X-ray is 5 MSV. In the case of cancer treatment, exposure doses of treatment area is over 10 sieverts for destroying cancer. Right side is radiation south from natural radiation. Symptoms appear over 100 MSV. Then, dose limits to workers handling nuclear energy or radiation is 100 MSV/5 years and below 50 MSV/Y. Natural radiation per person in Japan is approximately 2.1 MSV/Y. When we make business trip to other countries, for example New York, we receive doses 0.11 to 0.16 MSV. Ground radiation levels vary depending on geographic location, because natural background radiation is influenced by factors such as soil composition, altitude, and surrounding geological conditions. Some regions of the world have relatively high natural radiation levels, while others experience much lower values. In Japan, natural background radiation is generally low compared with many other countries, reflecting the country's geological characteristics. In particular, Sendai is known to have a relatively low average background dose, which is well below the global average. This means that people living and working in Sendai are normally exposed to only a small amount of radiation from natural sources in their daily lives. When evaluating radiation exposure at our facility, it is therefore important to consider this low background level as a reference point. By comparing occupational exposure with local natural background radiation, we can better understand that the additional dose received during properly managed RI work is very limited and well within safe levels. The maximum additional dose for IMRAM RI users is approximately 0.1 MSV per year, which is very small compared with natural background radiation. This level of exposure is comparable to, or even lower than, the annual dose that people receive from natural sources such as cosmic rays and terrestrial radiation in daily life. Therefore, radiation exposure during properly conducted experiments at the IMRAM RI facility is well controlled and maintained at a level that is considered extremely low from a radiation protection perspective. At low dose levels, such as those encountered in our facility, the health effects of radiation are extremely small and not clearly detectable by current scientific or epidemiological methods. In this low-dose range, any possible effects are so minor that they cannot be distinguished from normal variations in health status caused by everyday factors. Furthermore, proper safety management and strict radiation protection procedures ensure that radiation exposure is always kept well below levels known to cause harmful effects. Through controlled handling of radioactive materials, continuous monitoring, and compliance with established safety regulations, the risk to radiation workers is minimized to a level considered acceptable and safe. As a result, users can conduct their experiments with confidence, knowing that radiation exposure in our facility is carefully controlled and maintained at a very low level. Radiation exposure should always be minimized based on the ALERA principle, which stands for as low as reasonably achievable. This means that every reasonable effort should be made to reduce radiation exposure, taking into account technical, practical, and social factors, even when the dose is already well below regulatory limits. We must always balance the benefits of research and education with the potential risks associated with radiation exposure. By understanding radiation risks correctly and following established safety procedures, we can achieve meaningful scientific outcomes while keeping exposure at a minimum. This balanced approach ensures that radiation is used safely, responsibly, and effectively, in compliance with safety regulations and ethical standards expected of all radiation workers. Thank you for your attention. Please always prioritize safety and follow facility rules.